Hey, genuine reviews and constructive critics. How are you and your below today? It's activist composer Professor S. Suresh back with altruistic enthusiasm for my 90-second video on Anvil of publication on YouTube today, 9th of October 2020, Friday. Topic for discussion today is concurrent engineering and concurrent manufacturing concepts and principles. Concurrent means occurring or operating at the same time. Concurrent engineering, also known as simultaneous engineering, is a work methodology emphasizing the parallelization of tasks, that is, performing tasks concurrently. This is sometimes called simultaneous engineering, as I said before, or integrated product development using an integrated product team approach. It refers to an approach used in product development in which functions of design engineering, manufacturing engineering, and other functions are integrated to reduce the time required to bring a new product to market. A 2008 publication described concurrent engineering as a new design management system that has matured in recent years to become a well-defined systems approach to optimizing design and engineering cycles. Concurrent engineering has been implemented in a number of companies, organizations, and universities, most notably in the aerospace industry. Beginning in the early 1990s, CE was also adapted for use in the information and content automation field, providing a basis for organization and management of projects outside the physical product development sector for which it was originally designed. Organizations such as European Space Agency's Concurrent Design Facility make use of concurrent design to perform feasibility studies for future missions. The basic premise for concurrent engineering revolves around two concepts. The first is the idea that all elements of a product's life cycle, from functionality, production, assembly, testing, maintenance, environmental impact, and finally disposal and recycling, should be taken into careful consideration in the early design phases. The second concept is that design activities should be all occurring at the same time, that is, concurrently. The idea is that the concurrent nature of these activities significantly increases productivity and product quality. This way, errors and redesigns can be discovered early in the design process when the project is still flexible. By locating and fixing these issues early, the design team can avoid what often become costly errors as the project moves to more complicated computational models and eventually into the actual manufacturing of hardware. As mentioned, part of the design process is to ensure that the product's entire life cycle is taken into consideration. This involves establishing user requirements, propagating early conceptual designs, running computational models, creating physical prototypes, and eventually manufacturing the product. Included in this process is taking into full account funding, workforce capability, and time requirements. A 2006 study claimed that a correct implementation of the concurrent design process can save a significant amount of money, and that organizations have been moving to concurrent design for this reason. It is also highly compatible with systems thinking and green engineering. Concurrent engineering replaces the more traditional sequential design flow or waterfall model. In concurrent engineering, an iterative or integrated development method is used instead. The waterfall method moves in a linear fashion, starting with user requirements and sequentially moving forward to design and implementation until a finished product. In this design system, a design team will not quickly look backward or forward from the step it is on to fix or anticipate problems. In the case that something does go wrong, the design usually must be scrapped or heavily altered. The concurrent or iterative design process encourages prompt changes of tack so that all aspects of the life cycle of the product are taken into account, allowing for a more evolutionary approach to design. A significant part of the concurrent design method is the individual engineer is given much more say in the overall design process due to the collaborative nature of concurrent engineering. Giving the designer ownership is claimed to have improved the productivity of the employee and quality of the product based on the assumption that people who are given a sense of gratification and ownership over the work tend to work harder on the design and design a more robust product as opposed to an employee that is assigned a task with a little say in the general process. Concurrent design comes with a series of challenges such as the implementation of yearly design reviews, dependency and efficient communication between engineers and teams, software compatibility, and opening up the design process. This design process usually requires that computer models, computer-aided design, finite element analysis are exchanged efficiently, something that can be difficult in practice. If such issues are not addressed properly, concurrent design may not work effectively. It is important to note that although the nature of some project activities, project imposes a degree of linearity, completion of software code, prototype development and testing. For example, organizing and managing project teams to facilitate concurrent design can still yield significant benefits that come forward from the improved sharing of information. Service providers exist that specialize in this field, not only training people how to perform concurrent design effectively, but also providing the tools to enhance the communication between the team members. Cross-functional teams include people from different areas of the workplace that are all involved in a particular process, including manufacturing, hardware and software design, marketing, and so forth. Doing several things at once, such as designing various subsystems simultaneously, is critical to reducing design time and is at the heart of concurrent engineering. Incremental information sharing helps minimize the chance that concurrent product realization will lead to surprises. Incremental means that as soon as new information becomes available, it is shared and integrated into the design. Cross-functional teams are important to the effective sharing of information in a timely fashion. Integrated project management ensures that someone is responsible for the entire project and the responsibility is not abdicated once one aspect of the work is done. Several definitions of concurrent engineering are in use. The first one is used by the Concurrent Design Facility. Concurrent engineering is a systematic approach to integrated product development that emphasizes the response to customer expectations. It embodies team values of cooperation, trust, and sharing in such a manner that decision making is by consensus, involving all perspectives in parallel from the beginning of the product lifecycle. The second one is Wiener et al. 1988. Concurrent engineering is a systematic approach to the integrated concurrent design of products and the related process, including manufacturing and support. This approach is intended to cause the developers from the very outset to consider all elements of the product lifecycle, from conception to disposal, including quality, cost, schedule, and user requirements. Concurrent design and manufacturing involve simultaneously completing design and manufacturing stages of production. By completing the design and manufacturing stages at the same time, products are produced in less time by lowering the cost. Although concurrent design and manufacturing requires extensive communication and coordination between disciplines, the benefits can increase the profit of a business and lead to a sustainable environment for product development. Concurrent design and manufacturing can lead to a competitive advantage over other businesses as the product may be produced and marketed in less time. The success behind concurrent design and manufacturing lies within completing process at the same time while involving all disciplines. As product development has become more cost and time efficient over the years, elements of concurrent engineering have been present in product development approaches. The elements of concurrent engineering that are utilized are cross-functional teams as well as fast time to market and constrained manufacturing process when designing. By involving multiple disciplines in decision making and planning, concurrent engineering has made product development more cost and time efficient. The fact that concurrent engineering could result in faster time to market is already a major advantage in terms of a competitive edge over the producers. Concurrent engineering has provided a structure and concept for product development that can be implemented for future success. Concurrent and sequential engineering cover the same stages of design and manufacturing. However, the two approaches vary widely in terms of productivity, cost, development, and efficiency. Sequential engineering begins with customer requirements and then progresses to design, implementation, verification, and maintenance. The approach for sequential engineering results in large amounts of time devoted to product development. Due to large amounts of time allocated towards all stages of product development, sequential engineering is associated with high cost and is less efficient as products cannot be made quickly. Concurrent engineering, on the other hand, allows for all stages of product development to occur essentially at the same time. Initial planning, is the only requirement before the process can occur, including planning, design, implementation, testing, and evaluation. The concurrent design and manufacturing approach allows for shortening of product development time, higher efficiency in developing and producing parts earlier, and lower production costs. Concurrent and sequential engineering may also be compared using a relay race analogy. Sequential engineering is compared to the standard approach of running a relay race, where each runner must run a set distance and then pass the baton to the next runner and so on until the race is completed. Concurrent engineering is compared to running a relay race, where two runners will run at the same time during certain points of the race. In the analogy, each runner will cover the same set distance as the sequential approach, but the time to complete the race using the concurrent approach is significantly less. When thinking of the various runners in the relay race as stages in product development, the correlation between the two approaches in the relay race to the same approaches in engineering is vastly similar. Although there are more complex and numerous processes involved in product development, the concept that the analogy provides is enough to understand the benefits that come with concurrent design and manufacturing. Using concurrent engineering, businesses can cut down on the time it takes to go from idea to product. The time savings come from designing with all the steps of the process in mind, eliminating any potential changes that have to be made to a design after a part has gone all the way to production before realizing that it is difficult or impossible to machine. Reducing or eliminating these extra steps means the product will be completed sooner and with less wasted material in the process. During the design and prototyping process, potential issues in the design can be corrected earlier the product development stages to further reduce the production time frame. The benefits of concurrent design and manufacturing can be sorted into short-term and long-term. Short-term benefits are competitive advantage with implementing part into market quickly. Large amounts of same part produced in a shorter amount of time allows for early correction of part, less material wasted, less time spent on multiple iterations of essentially the same part. Long-term benefits are more cost-efficient over several parts produced in several years, large amounts of different parts produced in a shorter total amount of time, better communication between disciplines in company, the ability to leverage teamwork, and make informed decisions. Design axioms are the general truths which cannot be proven by any known methodologies or techniques. The following are some of them which are essentially followed by implementing concurrent engineering principles in product design and development process. Minimize the number of functional requirements and constraints. Satisfy the functional requirements from most important as first to least important as last. Minimize information content. Everything being equal conserves materials. Integrate functional requirements in a single part if they can be independently satisfied in the proposed solution. There may be several optimum solutions. Concurrent engineering is based on cross-functional and multidisciplinary teams representing various functional areas. Hence, in this approach, marketing, design, manufacturing, engineering, and all stakeholders in the product development process are brought together to discuss issues related to integration of functional design, manufacturing, quality control, customer service, and so on. This multifunctional team is responsible for addressing various issues such as the marketing services of the company feels that the tolerance range of 1 plus or minus 0.003 centimeter is too tight. The quality department finds the number of rejections is too high. The manufacturing and planning department wishes to use machine tools and better process capabilities. The purchasing department cannot buy more raw shafts because of the restricted availability of raw material. Why concurrent engineering? Increased product variety and technical complexity that prolong the product development process and make it more difficult to predict the impact of design decisions on the functionality and performance of the final product. Increasing global competitive pressure that results from the emerging concept of re-engineering, the need for rapid response to fast changing consumer demand, the need for shorter product life cycle, large organizations and several departments working on developing numerous products at the same time, new and innovative technologies emerging as at a very high rate, thus causing the new product to be technologically obsolete within a short period. Concurrent engineering is the application of a mixture of all the following techniques to evaluate the total life cycle cost and quality. Axiomatic design, design for manufacturing guidelines, design science, Design for assembly, the Taguchi method for robust design. Taguchi array and all that. Okay, manufacturing process design rules. Computer aided design for manufacturing. Group technology, failure mode and effects analysis, FMEA, value engineering, quality function deployment. Basic principles in concurrent engineering: start all tasks as early as possible, utilize all relevant information as early as possible, work structuring, systematically structure the work or work environment so that each task can be performed independently of each other, either by a machine or human or computer. Everyone participates in defining the objectives of the work. Operational understanding is achieved for all relevant information as team will work better if they know what other members are doing. Example, what constraints a team member would encounter when certain parameters will be changed. A strong commitment is made to adhere to the decisions taken earlier. Decisions are made in a single trade-off space. Decisions are robust, overcoming a natural tendency to resort to quick, novel decisions. Trust among teammates, trusting members if they agree to accept responsibility for a task, prefer to work together rather in isolation. This will also lead to better teamwork affinity. The team strives for consensus. The team should be empowered to make decisions in product development and should be given the ownership of what they produce. The team uses a visible concurrent process. Constancy of purpose. This requires a change in thinking beyond the goals of one's individual department or team to the company's goals. Aiming towards the constancy of the purpose results in everyone contributing his or her best, working towards a common set of consistent goals. Need for concurrent engineering: need to reduce product development lead time, increased competition, new manufacturing process develop more demanding customers. Concurrent engineering tools and techniques, design for manufacturing, design for assembly, failure effects and mode analysis, cost-driven design or target costing, quality function deployment, robust design through the Taguchi method, Puck's theorem, experimental design techniques, design stress analysis, benchmarking and competitive analysis, rapid prototyping, customer-focused design, computer and IT-based tools like CAD tools, mechanical, CAD tools, electronic, CAM, computer-aided manufacturing, computer-aided engineering tools in electronic information or data network. Advantages of concurrent engineering: faster time to market, which results in increased market share, lower manufacturing and production costs, improved quality of resulting end products, increased positioning in a highly competitive world market, increased accuracy in predicting and meeting project plans, schedules, timelines, and budgets, increased efficiency and performance, higher reliability in the product development process, reduced defect rates, increased effectiveness in transferring technology, increased customer satisfaction, ability to execute high and complex levels of projects while minimizing the difficulties, shorter design and development process with accelerated project execution, higher return on investment, reduced labor and resource requirements, overlapping capabilities and the ability to work in parallel, increased cohesiveness within the firm, lower implementation risk, faster reaction time in responding to the rapidly changing market, lower product and process design and development costs, improved inventory control, scheduling and customer relations. In industry, product lifecycle management is a process of managing the entire lifecycle of a product from inception through engineering, design, and manufacture to service and disposal of manufactured products. PLM, product lifecycle management, integrates people, data, process, and business systems and provides a product information backbone for companies on the extended enterprise. Nowadays, C is regarded as a key factor in determining the success of a company. C involves overlapping various stages in developing new products to reduce delays. This reduction of delay is achieved by intensively implementing the CE principles. These CE principles have been cited as the main keys for the rapid new product development process, and it was introduced by the Japanese firms. We are living in so-called space age, and people are craving more time at their disposal, and they expect everything to happen in a jiffy. It is like fast food culture. fast life, faster modes of transportation, fast cure for illnesses, etc. People also perish fast. Example, pandemics like COVID-19. Doing activities simultaneously in engineering, manufacturing, and assembly is a boon to industries since they can cater to the market requirements quite fast, cutting short the lead times for these activities. People are always in a hurry and do not have the patience to wait for things they need, even though they expect customized products and services. So, concurrency is enabling producers and service providers to dance to the tune of the customers. Main disadvantage is mistakes or errors might increase when we speed up. Higher speed, definitely more mistakes. We have already discussed the advantages. Debates, discussion on open-ended topics like this can go on forever. Anyhow, let me pull the plug here. We'll meet again real soon with another interesting topic. Some of the statements, views expressed are solely mine, based on limited knowledge gained over 6 decades of personal experience. Always watch these videos with closed captions, subtitles for absolute 100% comprehension has been a sincere recommendation. Zillion times so far. I know I rushed through to complete the presentation within 20 minutes max, which is a time limit. I had set myself to reading the viewer's attention as a now standard. I know nowadays I exceed this time limit since I make honest attempts to cover the selected topic more elaborately, including so many intricate fine details, referring a wide variety of sources, in particular Wikipedia, quite extensively, besides articles and books published recently. Besides, of course, I sprinkled my own salt and pepper and seasoned it with my personal experiences so far in my life and also intuition. Stay at home as much as possible to maintain social distancing attributed to pandemic now COVID-19 and prolong your lifespan. Lead a healthy life. God alone can put a stop to natural and unnatural events, maybe bio-war and cyber-war events like pandemics, which may lead to apocalypse and extinction of all sentient species on Earth for no fault of others. Rest in peace and harmony.